Hello friends, how are you? You would be fine, I think. So class, today we'll talk about the reverse osmosis. What we'll talk about the reverse osmosis. Okay, it is the remaining part of the osmotic colligative property. And today we'll also discuss some numericals based on osmotic pressure. Okay, so the remaining portion of the osmotic pressure we have already covered in our previous video. So I'll put the link below. Okay, I'll put the link below of the remaining portion of the osmotic pressure. So in this lecture we'll just talk about the reverse osmosis, which is also known as RO, and we'll discuss some numericals based on osmotic pressure colligative property. So first of all we'll start what is the meaning of this reverse osmosis. Okay, listen class, as you know, do you remember this diagram? Suppose it is a container, and on the right side of this container we are having the fresh water. Fresh water means it is having the low concentration. Fresh water having low concentration, no salt available here. And the left side of the container is having the salty water. Salty water means we are having the salt as a solute in this container. Okay, so this solution becomes what? It is highly concentrated solution. Are you getting me? So this fresh water, it is not having salt. This is what? Having the low concentration. And this is salty water. This is having high concentration because it is having salt as a solute. Do you remember? The concentration depends on the amount of the solute dissolved in the solution. Do you remember? So this salty water is having very large amount of the solute dissolved in it. So that's why it is considered as highly concentrated. And this fresh water is having either neither having the it is either having very small amount of the salt, or it is not having any salt in it. Okay, so that's why it is considered as the fresh water, or it is considered as the low concentrated solution. Okay class, now both the solutions are separated with the help of this semi-permeable membrane. Semi-permeable membrane, the membrane which will allow only the solvent particles to move from one solution to the other solution. Okay, so this semi-permeable membrane, it is actually made up of cellulose acetate. It is made up of cellulose acetate. Do you remember class? Cellulose is what? It's a kind of polymer which is found in the plants. Okay, so cellulose acetate, it is a synthetic polymer. Okay, so it is a synthetic polymer. Something is done in the natural cellulose. Okay, some chemical reactions are done, and with the help of this we just create what? Cellulose acetate. So this semi-permeable membrane is made up of cellulose acetate. Now the thing is, what is the meaning of this reverse osmosis? Listen class, what will happen? This is the fresh water having low concentration. This is the salty water having very high concentration. Obviously something will happen, and both the solutions are separated with the help of the semi-permeable membrane. So ultimately in the both solutions, what will happen? The osmosis will take place, and the osmosis, as the osmosis starts, the fresh water, from the fresh water, the solvent molecules means the water molecules will start moving from right solution to the left solution, low concentrated solution to the highly concentrated solution. यहाँ से यहाँ water molecules start करेंगे move करना, because water molecules are the solvent, so they'll move from fresh water to the salty water. Okay, as the osmosis takes place through the semi-permeable membrane. The most important thing, as they are moving, what will happen? The level of the water in this salty water is going to increase. The level of this fresh water in the salty water is going to increase, and due to which a kind of pressure would be exerted on this piston. यहाँ से water यहाँ move कर रहा है, तो यहाँ water का amount बढ़ रहा है. As the water volume increases, ये यहाँ तक आएगा और ये एक पिस्टन के ऊपर प्रेशर डालेगा. आर यू गेटिंग मी? और इससे पिस्टन थोड़ा सा ऊपर मूव करेगा. द पिस्टन विल मूव अप. आर यू गेटिंग मी? वाटर ऑस्मोसिस हुआ, and the water is moving from the fresh water to the salty water, highly concentrated, from the low concentrated solution to the highly concentrated solution. As the water is moving, जैसे से वाटर मूव कर रहा है, यहाँ पे वाटर का अमाउंट बढ़ रहा है, वाटर का अमाउंट बढ़ रहा है, तो ऑब्वियसली ये जो पिस्टन है, ये फ्रिक्शन लेस पिस्टन है, एकदम से इसके ऊपर प्रेशर एक्सर्ट करेगा और पिस्टन थोड़ा ऊपर आएगा. आर यू गेटिंग मी? नाउ लिसन. जैसे ही हम पहले भी वी हैव ऑलरेडी टॉक्ड अबाउट दिस काइंड ऑफ फिगर, ओके, व्हेन वी वर जस्ट टॉकिंग अबाउट द ऑस्मोटिक प्रेशर. डू यू रिमेंबर? In the previous video we have already discussed it, okay, but we haven't discussed the reverse osmosis. So as the piston will move up, now suppose if we press the piston again, if we press this piston again, okay, and as we start pressing this piston, the जो वाटर यहाँ से यहाँ मूव कर रहा था उसका फ्लो यहाँ थोड़ा कम होना शुरू हो जाएगा, ओके. फिर हमने और पिस्टन को प्रेस किया, फिर वो और फ्लो उसका कम हो जाएगा क्योंकि ऊपर से प्रेशर पड़ रहा है. अब मैं पिस्टन को धीरे 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 प्रेस करता जा रहा हूँ, जिसकी वजह से जो ऑस्मोसिस, एज द ऑस्मोसिस वाज टेकिंग प्लेस, अल्टीमेटली व्हाट विल हैपन, द रेट ऑफ द ऑस्मोसिस विल रिड्यूस एंड एट अ पॉइंट विल कम, जब हम पिस्टन को प्रेस करते रहेंगे, कि वाटर का यहाँ से मूव करना बिल्कुल बंद हो जाएगा क्योंकि ऊपर से प्रेशर पड़ रहा है. अगर ये ऊपर से प्रेशर पड़ रहा है, मान लो ये वाटर, ये जो हमारा फ्रेश वाटर है यहाँ सॉल्टी वाटर में मूव कर भी रहा है, ऑस्मोसिस हो रहा है, सो अल्टीमेटली व्हाट विल हैपन, जैसे जैसे वाटर यहाँ मूव करेगा पिस्टन के ऊपर तो प्रेशर पड़ेगा ही ना, पड़ेगा. बट पिस्टन पे प्रेशर पड़ने के लिए हम क्या करें, पिस्टन को हमने पहले से प्रेस कर रखा है, तो वाटर ऊपर यहाँ पे मूव ही नहीं कर पा रहा है ऊपर, तो वाटर कहाँ जाएगा, ऑब्वियसली वाटर मूव करना थोड़ा सा स्टॉप हो जाएगा. धीरे धीरे हम पिस्टन को और प्रेस करेंगे. A time will come, a point will come when the movement of the water from the fresh water to the salty water, it will get stopped, okay. अब water यहाँ से यहाँ move नहीं करेगा, ultimately क्या होगा, osmosis रुक जाएगा. The pressure, do you remember we have already talked about this in the previous video, the pressure at which the minimum pressure or the minimum pressure which is required to stop the osmosis is called osmotic pressure. This is called osmotic pressure. So इस प्रेशर पे जो ऑस्मोसिस है वो रुक गया. सपोज मैंने पिस्टन और प्रेस करा, मतलब पहले ऑस्मोटिक प्रेशर तक प्रेस करा, ऑस्मोसिस रुक गया. अब मैंने और पिस्टन प्रेस किया ना, तो पता क्या होगा, अभी तो वाटर मूव कर रहा था यहाँ से, अब प्रेस करने से वाटर सॉल्टी वाटर से फ्रेश वाटर मूव करने लगता है. आर यू गेटिंग मी? ये ऐसे हो जाएगा, रिवर्सल हो जाएगा इनका, ओके. और यहाँ से सॉल्टी वाटर, दिस इज हाईली कॉन्सेंट्रेटेड सोल्यूशन वी नो, बट द थिंग इज इट इज कॉन्सेंट्रेशन, इट इज हैविंग द वाटर ना, सॉल्ट एंड वाटर बोथ द थिंग्स आर प्रेजेंट हियर. तो हम प्रेशर और एक्सर्ट करेंगे तो ऑस्मोसिस तो रुक ही गया, लेकिन और ऑस्मोटिक प्रेशर से भी ज़्यादा अगर हम प्रेशर एक्सर्ट करेंगे तो वाटर जो है वो सॉल्टी वाटर से मूव करके फ्रेश वाटर में मूव करना स्टार्ट कर देगा. आर यू गेटिंग मी? तो ये जो उल्टा इसका रिवर्सल जो मूव करना शुरू हुआ, ये जो हुआ ना, ये सॉल्टी वाटर से फ्रेश वाटर में जब वाटर मूव करना शुरू कर देता है, ठीक है, तो इसको हम क्या बोलते हैं, रिवर्स ऑस्मोसिस. व्हाई दिस इज नोन एज रिवर्स? बिकॉज ऑस्मोसिस, डायरेक्शन ऑफ ऑस्मोसिस इज right solution to the left solution. But what happened when the pressure more than osmotic pressure, just remember this is the osmotic pressure, when the pressure more than the osmotic pressure is exerted, more than osmotic pressure पे तो osmosis रुका था, हमने osmotic pressure से भी ज़्यादा pressure exert कर दिया. So whenever we exert the pressure which is more than osmotic pressure, तो क्या होता है, जो हमारा वाटर है वो सॉल्टी वाटर से फ्रेश वाटर की साइड में मूव करना शुरू कर देता है, और जिसको हम बोलते हैं रिवर्स ऑस्मोसिस. आर यू गेटिंग मी? सो क्लास, इन शॉर्ट व्हाट आई टोल्ड यू, whenever the pressure more than osmotic pressure it is exerted at the highly concentrated solution, the water from highly concentrated solution starts moving from the highly concentrated solution to the fresh water or low concentrated solution, and this is called what? Reverse osmosis. So this is nothing but the reversal of the osmosis. Is it clear? Again, I am telling you the definition. Whenever the pressure more than osmotic pressure is exerted, the water from highly concentrated solution starts moving towards the low concentrated solution or the fresh water, okay, or इस process को through the semi permeable membrane. This process is known as reverse osmosis. The most important thing is we'll have to exert the pressure more than osmotic pressure. Pi is the osmotic pressure, we are exerting the pressure more than osmotic pressure. This is the most important thing. Now यहाँ से यहाँ water move करना शुरू करता है. जब यहाँ से यहाँ उल्टा reverse हो जाता है, यहाँ the level of the water will increase और यहाँ से water droplets will come out. And what kind of water we are getting here? Fresh water or clean water. यहाँ से जो move करेगा salty water से, जो fresh water में water move करेगा, obviously it is also a clean water, fresh water. Why? Because only the water molecules can move through the semi-permeable membrane. Do you remember? So only the water molecules will move from salty water to the fresh water. So ये जो salty water है, इससे हमने सारा fresh water जो था, जो water main water था, वो हमने यहाँ से यहाँ ले लेंगे. This is called reverse osmosis. It means what is happening? We are converting the salty water into the fresh water. This salty water we are converting into the fresh water, and this fresh water we can drink. So this reverse osmosis, actually it is used for desalination of the seawater. You know, it is very difficult. We cannot drink the seawater. You would be aware of it. We cannot drink the seawater. Okay. So because it is having very high concentration of the salt, but with the help of the reverse osmosis, we can convert the seawater into the fresh water, and fresh water we can easily drink. So desalination plants, they have been set up in various countries, and in India as well. In Tamil Nadu, desalination plant was established, but the thing is, the separation or the reverse osmosis cost was very high. So the cost of water was very high, so it was not affordable for all the common people. But it is also, this reverse osmosis and the reverse osmosis plant is working in various other countries like Dubai or some other countries where there is a very, the drinking water is not very large. In India, there is no problem for the drinking water, but in some other nations where there are the deserts, so they require the drinking water, fresh water. So obviously the establishment of the desalination plant is also required in those type of countries. Now class, we'll talk about the numericals based on the osmotic pressure. First numerical is calculate the osmotic pressure at 273 Kelvin of 5% weight by volume solution of urea. Molar mass of urea is 60, it is given, and the value of R is also given here. Okay, now they are asking, we'll have to find out the osmotic pressure. Okay, temperature is also given, mass of the solution and the volume of the solution is also given. Now listen, we know the formula of osmotic pressure is pi is equal to CRT. C is what? Molarity. And R and T, R is what? Solution constant, and T is the temperature. Now what is given in the question? It is saying 5% volume, 5% weight by volume solution of urea. It is given. Listen, 5% weight by volume solution of urea. Weight by volume solution of urea means what? 5% weight by volume means 5 gram of urea in 100 ml of solution. Do you remember? 5% weight by volume means 5 gram of urea in 100 milliliter of solution is given. Okay, so 5 gram urea, it means we know the weight of the urea is given, it would be 5 gram, and it is dissolved in 100 ml of solution. It means the volume of solution is also given, it is 100 ml. Are you getting me? Now the temperature The temperature is also given in the question, 273 Kelvin temperature. Okay. Now, the molar mass of urea. Urea is what? It's a solute. The molar mass of solute is also given in the question. It is 60. Okay. And the value of the R is also given in the question. Okay. Everything it is given in the question. Now, what is osmotic pressure? Osmotic pressure is what? Molarity into R into T. Molarity, formula of molarity is what? Number of molarity, formula of molarity is what? Number of moles of solute divided by volume in liter, R into T. And number of moles of solute means, we know number of moles. Number of moles is equal to what? Given weight of solute divided by molar mass. This is the formula of number of moles. So now number of moles of solute we have put here, given weight divided by molar mass. So given weight of the solute is what? 5 gram we have put here. Okay. The next thing is divided by molar mass. It is 60. So 5 by 60. Given weight of the solute divided by molar mass of the solute we have put here. And this is the volume of the solution. It is 100. It is given here in the question. So 100 is the volume. So as the volume is given in milliliter, so we'll have to multiply this with 1000. So after calculating, after the calculation we'll get, and after putting the values of R and the temperature, so after calculation we'll get 18.655 atmosphere. So this would be the osmotic pressure of the given solution. I hope it would be clear to all of you. Now we'll move on to the other numerical. Now the next numerical is a 5% solution of cane sugar, molar mass is also given 342, is isotonic with 0.877% solution of urea. So calculate the molar mass of urea. The question is 5% solution of cane sugar, molar mass is 342, is isotonic with 0.877% solution of urea. Calculate the molar mass of urea. Now listen class. The question says it is two solutions are given. One is 5% solution of cane sugar. Other one is 0.877% solution of urea. Two solutions are given. 5%, 0.877% solution of urea. Both the solutions are isotonic. Do you remember what is the meaning of isotonic solutions? Isotonic solution means both the solutions are having the same osmotic pressure. We have already discussed about the isotonic solution in our osmotic pressure video. So if you really want to know what is the meaning of all these things, I have given the link below. So you can press the link and you can get the information regarding the remaining part of the osmotic pressure. Now isotonic solution means both the solutions are having the same osmotic pressure. Suppose the pi 1 is the osmotic pressure of 5% solution of cane sugar. So and pi 2 is the osmotic pressure of the second solution, which is of urea. So both the solutions are isotonic. It means they would be having the same osmotic pressure. Are you getting me? तो हमें क्या करना है कि इन दोनों का जो ऑस्मोटिक प्रेशर है अलग अलग हमें निकालना है, क्योंकि दोनों आइसोटोनिक हैं. पहले वाले सोल्यूशन का भी हमें ऑस्मोटिक प्रेशर निकालना है, सेकंड सोल्यूशन का भी हम लोगों को ऑस्मोटिक प्रेशर निकालना है. एंड आफ्टर फाइंडिंग द ऑस्मोटिक प्रेशर ऑफ बोथ द सोल्यूशन वी विल हैव टू पुट व्हाट, उन दोनों को इक्वल रख लेना है. इक्वल रखकर जो भी हम कुछ कैलकुलेशन करेंगे ईजिली वी कैन गेट द मोलर मास ऑफ द यूरिया. ओके, तो हम स्टार्ट करते हैं. सबसे पहले फर्स्ट सोल्यूशन, इट इज़ 5% सोल्यूशन ऑफ केन शुगर. सो नाउ क्लास वी हैव ऑलरेडी डिस्कस्ड इन द लास्ट न्यूमेरिकल, अभी हमने डिस्कस किया है जस्ट कि 5% सोल्यूशन ऑफ केन शुगर मीन्स 5 ग्राम केन शुगर. द 5 ग्राम केन शुगर इज प्रेजेंट इन 100 ml ऑफ सोल्यूशन. So the mass of the cane sugar is also given 5 gram and the volume of the solution is given, it is 100. एक ही चीज़ से 5% से हमें दो चीज़ें मिल जाती हैं. परसेंटेज जब भी गिवन होगी उससे एक चीज़ होगी, बट हमें दो चीज़ें मिल जाएंगी. नंबर वन इज़ द वेट ऑफ द सॉल्यूट, अदर वन इज़ द वॉल्यूम और द मास ऑफ द सॉल्यूशन. सो यहाँ से हमें इसका वेट ऑफ केन शुगर मिल गया यहाँ पे, और हमें यहाँ पे 100 ml सोल्यूशन मतलब वॉल्यूम भी हमें मिल गया। सो 5% हमें मिल गया। सो मास ऑफ द सॉल्यूट मतलब केन शुगर इट इज़ 5, वॉल्यूम ऑफ द सोल्यूशन इज इट इज़ 100, okay, and molar mass of the solute means cane sugar, it is also given, this is 342, it is given in the question, okay. So pi value of the osmotic pressure is molarity into R into T, and the molarity is what? Molarity, the formula of molarity अभी हमने डिस्कस किया पिछले न्यूमेरिकल में। molarity का फॉर्मूला क्या होता है? number of moles of the solute divided by volume of the solution, and number of moles of solute means क्या होता है? नंबर ऑफ मोल्स मतलब गिवन वेट डिवाइड बाय मोलर मास। सो गिवन वेट मैंने यहाँ लिख दिया, देखो। मोलैरिटी मतलब नंबर ऑफ मोल्स ऑफ सॉल्यूट डिवाइड बाय वॉल्यूम ऑफ द सॉल्यूशन। सो नंबर ऑफ मोल्स ऑफ सॉल्यूट इज गिवन वेट ऑफ द सॉल्यूट डिवाइड बाय मोलर मास ऑफ सॉल्यूट, एंड दिस इज द वॉल्यूम ऑफ द सॉल्यूशन। W2 इज द वेट ऑफ द सॉल्यूट, एंड M2 इज द molar mass of the solute, V is the volume of the solution, RT is given. So after putting the values, W2 is weight of the solute 5 gram, molar mass of the solute is given 342, हमने यहाँ रख दिया। RT ऐसी रहेगा because the volume of the solution is given milliliter, so we'll have to multiply with 1000, हमने multiply कर दिया। So यहाँ ये सारी चीज़ें हमें कैलकुलेट नहीं करना है, ये ध्यान रखना। जब भी whenever it is given isotonic solution, there is no need to calculate, just we'll have to find out the first osmotic pressure value, okay। हमने यहाँ से निकाल लिया osmotic pressure। अब next case is what? It is given 0.877% solution of the urea, okay, 0.77, so it means क्या हुआ? 0.77% solution of urea means the mass of the urea, again I have told you so many times, the mass of the urea becomes what? 0.877, and the volume of solution will become what? 100 milliliter. Are you getting me? बिल्कुल वैसी क्या है जैसे ऊपर वाले में किया मैंने। 5% केन शुगर सोल्यूशन मतलब 5 ग्राम केन शुगर, 100 ml 100 ml हमारा सोल्यूशन होगी, सोल्यूशन का वॉल्यूम। इन द सेम मैनर 0.877% solution of urea means 0.877 gram of urea or in 100 ml of solution. Molar mass is not given. Listen, molar mass is not given anywhere, and they are asking we'll have to calculate the molar mass of urea. So molar mass is not given. So this is the formula of osmotic pressure. Again, osmotic pressure means W2 mass of solute divided by molar mass of solute, RT into volume of solution. We have put here, listen, mass of solute is given 0.877, molar mass we'll have to calculate, suppose it is M2, RT, R and T we'll have to put here, and the volume of the solution is given 100 ml, as it is ml, and as it is in ml, so we'll have to multiply this with 1000, okay. Now this is the second equation, and this is the osmotic pressure of the second solution, okay. So both we are having pi 1 and pi 2. What we'll have to do, because both the solutions are isotonic with each other, so we'll have to put both the osmotic pressure equal to each other, okay. हमने equal रख लिया यहाँ पर। अब मैंने पहले वाले की वैल्यू सारी यहाँ रख दी, दूसरे वाले की वैल्यू यहाँ रख दी। अल्टीमेटली क्या हुआ? RT से RT कैंसिल हो गया, 1000 से 1000 कैंसिल हो गया, 100 से 100 कैंसिल हो गया, सब कुछ कैंसिल हो गया। बचा क्या? ये 5 बचा, ये 342 बचा, 0.877 बचा और बाई M2 बचा। इसकी क्रॉस मल्टीप्लिकेशन की, और क्रॉस मल्टीप्लिकेशन के बाद हमें ये मिला, और उसके बाद जब हम इसको कैलकुलेशन करते हैं, वील गेट व्हाट? द मोलर मास ऑफ द यूरिया, एंड इट इज़ 60। सो दिस इज़ वेरी इजी न्यूमेरिकल। लिसन क्लास, अगेन आई एम टेलिंग यू, बहुत इजी न्यूमेरिकल्स हैं, सब इजीली समझ आ जाएंगे। बस आइसोटॉनिक जहाँ पर आ जाए ना, तुम्हें क्या करना है, 2 सोल्यूशन गिवन होंगे और उन दोनों के बीच में लिखा होगा ये आइसोटॉनिक है। सो व्हाट यू विल हैव टू डू, ओनली उन दोनों की ऑस्मोटिक प्रेशर की वैल्यू निकालो और दोनों को इक्वल रख लो, और जो भी निकालना हो, अभी मोलर मास का है, कभी वो पूछेंगे इसमें से वेट ऑफ सॉल्यूट निकालो एक में, दूसरे का मोलर मास निकालो। ऐसी डिफरेंट काइंड्स ऑफ क्वेश्चंस दे कैन आस्क यू, ओके। ये कई सारे बोर्ड्स में भी आते हैं, और बहुत सारे एंट्रेंस एग्जामिनेशंस में भी इनको पूछा जाता है, तो तुम्हें इसी तरीके से निकालना है, सबका मेथड एक ही है। ओके, तो अब मैं इस वीडियो को क्लोज कर रहा हूँ। इसके जितनी भी इस कॉलिगेटिव प्रॉपर्टी, ऑस्मोटिक प्रेशर कॉलिगेटिव प्रॉपर्टी से रिलेटेड जितनी भी इंफॉर्मेशन है इस वीडियो के अलावा, वो सब एक और वीडियो है जिसमें जो मैंने पहले बनाया था ऑस्मोटिक प्रेशर, तो मैं उसका लिंक जो है वो नीचे दे रहा हूँ, वहाँ जाकर उसे प्रेस करो और जितनी और रिमेनिंग पोर्शन इसका रह गया ऑस्मोटिक प्रेशर का, वहाँ से जाकर उसको क्लियर कर लेना। ओके, सो नाउ it was for the today's class. Goodbye. Have a nice day ahead.